Alright guys, hey, welcome back to another lesson. Okay, today we're going to talk about multiplying matrices together. Alright, we talked about how to multiply a scalar. Okay, that's a number that's outside of the matrix. But we never talked about how to multiply two matrices together. And there's a lot of different, well, I wouldn't say a lot, but there are some certain rules that we have to abide by. Okay, so let's go ahead and just jump right into it. So I want to start off with kind of like a word problem in a way. So this table right here shows the scoring summary for Lisa Leslie, the WNBA's all-time scoring leader. We have to create a matrix B, okay, for a summary of the baskets she made. Then create a matrix P for the point values for each type of basket. How can you find the total number of points scored each season? Now we can do this without a matrix, okay? But I think this is kind of a nice way to get into this topic here. So what I'm going to do, I'm going to bring out this whiteboard, all right? And what I did essentially is I just took the values from that frequency table and boom, there's your matrix, right? Okay. So here's all my point values, or how many I've scored, I should say. So the first row were the number of field goals. The second row is the number of three-pointers. And the last one is the number of free throws that she put together. So this, what do they want to call it here? Is it what, matrix B? So here's matrix B, okay? Over here would be matrix P, the point values, okay? And notice 2 points for every field goal, 3 points for every three-pointer, 1 point for every free throw is what I have here. Now you're probably asking, okay, why did I make this specifically this size matrix? So let's take a look. This guy is a 1 by 3 matrix, and this guy over here would be a 3 by 4 matrix right there. Okay. So if I were to figure this out, you would probably say, well, Mr. McCullough, what I would do is I'd take the first row and I'd multiply it by 2. Right? 2 points for every field goal. And I'd take this row, multiply by 3 for every three-pointer. And the last row I'd multiply by 1 for every three-point throw, and then I'd get my final result. And you'd be absolutely correct. Doing it in terms of a matrix, it's just a little different. So what I would essentially do here, okay, and pause the video and think about how I'd multiply these, because I can't just pick this guy apart and say 2 goes to here, 3 goes to here, 1 goes to there. There's a process behind it. Essentially what I'm going to do is I'm going to take this entire row and I'm going to multiply it by this entire column. So that way, every element in this matrix, make sure the TV can turn off, every element in this matrix is going to be paired up with an element in this matrix. Okay? So I'm not taking one element and pairing up with multiple elements here. That's not what multiplication is for this condition. Okay? Scalar multiplication is, but not matrix. So what I would essentially do is take the 2 multiplied by 197, right? That's 2 points for every field goal. 3 times every three-pointer, and 1 times every free throw, okay? So then, once I get my answers, I'm going to go ahead and take this row again and multiply it by the second column, pairing it up the same way. 2 goes with the 249, 3 goes with the 8, 1 goes with the 158. So when I multiply these guys, I'm going to do a row by column. Okay, does that make sense? Row by column. Now, if you look at the dimensions of this matrix, the sizes are going to be different, but there is something that has to be the same here. For me to actually perform this multiplication, look at the middle values here. Okay? Notice something, that the number of columns in this first matrix matches the number of rows in this matrix. Okay? So, for instance, there are 3 values here, right? 3 columns, 3 values. So my row has to have 3 values listed here as well, right? 3 for 3. I can't do a row by a row because, look, I got 3 here. If I multiply by this entire row, I have 4 values. So I'm missing an element to multiply by. Does that make sense? So if I'm going to multiply two matrices, the columns of the first have to match the number of rows in the other guy. Because if not, every element in one matrix will not match up to the element in the other guy. Okay? So that's what we're going to do for the first couple examples is, can we multiply two matrices based on just their dimensions? And then we'll talk about actually multiplying these guys. Now the outside numbers, and this is going a little bit ahead, but the outside numbers are going to represent the new matrix, the size of our result, the new matrix. So when I multiply these two, my answer is going to be a size of a 1 by 4 for my final result. Okay? So just keep that in mind, that the middle values, the columns of the first have to match the rows of the second, because every element has to get matched up with something. And then the outside numbers end up being the new matrix size. Okay? Questions, thoughts, concerns, dilemmas? I just feel like just showing you like an actual word problem, like a context problem, you can see why we're multiplying it by a row and a column. Okay? I can't multiply this with the whole entire row here because field goals are just 2 points. They're not 2, 3, and 1. So there's a reason why we're multiplying in a certain method here. Now, there are 5 ways. There's a lot of ways to multiply matrices. And for just a high school class, we're only going to multiply row by column. That's how we're going to do it. Okay? We're not going to worry about other methods of doing it. We're not going to do a grouping method or anything like that. We're always going to multiply from left to right. We're not going to multiply from right to left. Okay? It's not going to be the same thing. The commutative property will not work when it comes to matrices. Okay? All right, so I apologize for that being a little bit longer, but I just feel like it's very important to see how we're starting this lesson out. So I'm taking a sip of tea there. All right. Determine whether the product of these two matrices is defined. If so, state the dimensions. So matrix A is a 3 by 4 matrix. Matrix B is a 4 by 2 matrix. Okay? So I'm not asking to do the multiplication. I'm asking, can you? Or based on what I just said originally, the middle values, the columns of the first, have to match the rows of the second one. So because they do match, yes, okay, I can multiply. It's going to happen because every element for this guy will match up with an element for this guy. The outside is the new dimensions. So the new matrix is going to be a 3 by 2. And I'm done multiplying. That's it. Okay, there's problem 1 done. Okay. Did it change? Oh, it did change. There we go. It's like the same problem. I'm only changing those, so it's hard to tell if I changed to a new slide. Okay, so new dimensions. And pause the video, try it out for yourself. The first matrix is a 3 by 2. The second matrix is a 4 by 3. Okay. Am I allowed to multiply these? No. There's only 2 columns here, and there's 4 rows for that guy. So that's telling me that not every element here will be paired up with an element here when I multiply. So just like adding, when the dimensions don't match up, some elements are being missed. So this would be impossible. Impossible to multiply. Okay. Now, I don't know if some of you might be thinking ahead. You're like, well, wait a minute. If I change this, if I change the columns and rows for both of them, it might work out, and it does. But that might change what you're looking for as well. Because if we're doing something as a word problem where it does matter if we change the positions of these guys because they represent different things, it can get messy. Okay. So, final one, and then we'll go to actual multiplying. Okay, so we have a 3 by 2 and a 2 by 3. I'll write it up over here. So 3 by 2, 2 by 3. So I can see that the inner dimensions match, so I am allowed to multiply. The result is going to be a 3 by 3 matrix when I'm finished. Okay, there we go. that's just part one. Okay. Part two is, well, let's actually multiply these guys. Okay. So what I'm going to do for part two, I'm actually going to stop the video here. Okay, and I'm going to clip to part two. So just hold on one second.